Hello, you're with Bahati Abdul Karim, and I'm taking you through A-Level Applied Mathematics. This time around, probability theory. Let's look at what we're going to study today. In probability theory, we're going to look at probability basics and notations, undefined events, mutually exclusive events, independent events, exhaustive events, and lastly, conditional probability. Let's start with the definition of probability. Probability is the measure of chance of an event occurring or not occurring. And in any statistics experiment, there will be a number of different outcomes. And the set of all possible outcomes is called the sample space of the experiment. For example, if a normal dice is thrown, the sample space would be 1, 2, 3, 4, 5, and 6. An event is a collection of some of the outcomes from an experiment. For example, getting an even number on the dice or scoring more than 40 on the quiz. Let's look at probability of an event. Given an event E over a sample space S, since we now know an event and a sample space, probability of any event will be given by number of events out of the number of sample space. Example 1. Find the probability of getting 2 heads when an ordinary coin is tossed thrice. And here is our sample space. You may throw for the first time you get a head, for the second time you get a head, and for the third time you get a head. Or you may throw for the first time you get a head, the second time you get a head, and the last time you get a tail. And all these outcomes are possible. Then, the event we want is getting 2 heads. You see that here we have a head and a head, here we have a head and a head, and here a head and a head. So as we know that probability will be the number of events out of the number of sample space, we shall say our number of events is 3 and the number of sample space is 8. So we shall have our probability equal to 3 out of 8. Here we have example 2, which says that find the probability of getting a number greater than 3 when ordinary die is tossed once. This is the sample space for an ordinary die. And the event of getting a number greater than 3, you will have a 4, a 5, or a 6. And your probability will be a half. That is 3 out of 6, which gives you a half. Our example 3 says a dice is thrown twice and the scores obtained are added together. Find the probability that the total score is 6. So here we draw our box for the sample space. So we have the first throw and we have the second throw. For the first dice, we have it numbered from 1 up to 6, and the second one also numbered from 1 up to 6. So when we throw once, we expect to get a 1 and a 1, which gives us a total of 2. And when you throw once, for the first dice, you may get a 2, and the second dice, you may get a 1, which gives you a total of 3. You may throw the first time, you get a 3, and you throw the second time, you get a 1, which gives you a total of 4. and you continue like that. Or you may throw, for the first dice you get 6, and the second time you get a 5, which will give you a total of 11. So this is our sample space. And they want us to find the probability that the total score is 6. So we have to look for the score of 6, which is here. All these are total scores of 6. Then there are 36 equally likely outcomes. All these are 36 outcomes. And then 5 of the outcomes result in a total of 6. If you count them, 1, 2, 3, 4, 5. They are 5 outcomes out of the 36 outcomes. And this will give us a probability for the total of 6 as 5 out of 36. This notation here means probability that the total is equal to 6. You should always define it before you use it, because this is not a universal thing. Next we have, if A is an event arising from a statistical experiment, then the probability that A occurs is denoted by P of A, where this probability will lie between 0 and 1. So it can be a 0, or it can be a 1, or it can lie in between these two values. You should never get a probability which is greater than 1 or which is a negative. It will be wrong. If A is certain to happen, then the probability of A will equal to 1. For example, the probability of starving if you refuse to eat food for many days. If you refuse to eat food, you will finally starve. So the probability in such a case is 1. If A is impossible, then the probability of A will be a 0. For example, the probability of passing without reading will be a 0. It's very impossible. You cannot pass without reading. The probability that A does not occur is denoted as P of A complement. And P of A complement will always be equal to 1 minus probability of A. Probability of A not occurring will always equal to 1 minus probability of A occurring. And then, let's look at intersection of events. For any two events, A and B, the probability that A and B occur together is A intersection B. Then, union of events. For any two events, A and B, the probability that event A or B or both occur is P A union B. And P of A union B will always equal to probability of A plus probability of B minus probability of A intersection B. Probability of A or B will be given by probability of A plus probability of B minus probability of A and B. Then, complement of events. A complement denotes event A does not occur. For events A and B, then probability of A plus probability of A complement will always equal to 1. The same applies to probability of B. And probability of A union B plus probability of A union B complement will also equal to 1. And lastly, probability of A intersection B plus probability of A intersection B complement will also equal to 1. So for this lesson, we are going to stop here. And in the next lesson, we are going to look at the contingence table and De Morgan's rule. You can give us a thumbs up if you like the video. Subscribe to our channel if you want to get updated whenever we release a video. And you can also give us a comment in the comment section. Thank you for watching. May God bless you.